Very good. Now then, what is the next thing? Now this is also very good. You have the S device here. Now I just want to show you a few things. You can you can now what you're doing is that you sweep the drain to a certain voltage, right? And then yeah, and then you sweep the gate to 10 volt. And then we have another instance that we try to sweep from the again, right, to the negative direction. This is not the best way, right? Because then we need to plot two curves. You actually can do it in in one way, like this, right? So what you can do is this. You can looks like a waste of time, but it won't. It will waste some time. That is true. But you then have one single file, right? So what you're doing is good, but you need more post-processing. So what you can do is still you sweep this to negative 10 volt, and then just do this. Actually, what you already have this, right? Instead of do 0, you remove do 0, and then sweep it back to 10. So what it does is that you will get a single curve that is from negative 10 to 10. Is that okay? Also, our goal is not that much. Let's just go to 1.5 for here. Okay. Now, then you may say, then I have a lot of data, right? If you remember, if you look at the curve, somehow you have this straight line. Why is that? Because this is when you were sweeping the VD when VG equals to 0. Okay, so you don't want this data, and there's a way to do that. What we can do is that we can say, I forgot all the command. You can say, when I want to store, then I store a new file, right? I will say n note at, let's say, just idvg, for example. I hope that I have the new fix maybe, right? So I forgot the command again. We can go to the menu, look at the Centaurus device, and then look for new current prefix, right? New current prefix. New current, not new file. New current prefix. New current prefix. So what would it do, right? So let's take a look quickly. So in order to make this fast, now I just remove the mesh, right? I try to make the mesh coarse so that I'm just screwing up the simulation, but this is just demo. You can change back the mesh. Let's save it, right? So let me just look at this tool. I control and then highlight them, and then I run them, right? So with this, originally you have a mesh count, okay, 4,000, which is pretty good already. Now you also see something, this one keep popping up. You don't want to sit there and then close it. What you want to do is right click, property, and put -e. No, even don't need to do that. Just choose batch, okay, not interactive. Then it won't pop up again in the future, right? For example, now I try to run this. It will just finish without popping up. Okay, yeah, then otherwise, if you have a 1,000 job, you're going to click 1,000 times, right? So this one just close by itself. So, okay. Now this is running not good convergence because we have a coarse mesh, but the main, so maybe coarse mesh is actually making it slower. But anyway, you see that it's ramping up, right? So now if I try to open it, you see that it is still here, not at my place. Oh, maybe I've changed the wrong file. Yeah, indeed, I changed the wrong file. I actually should run this one. This one should be the one I need to run because the file I was editing was for this node. Okay, so let's just take a look. Right. So this one is fast now, right? So it ramp up the drain. As you can see, the drain voltage goes up. And after that, goes up to 1 volt, right? Then after that, it will random the gate to negative. It is going to be, yeah, negative. Now, but now if you try to open now, you don't see any, you don't see the new file, right? Oh, but when I open it, just created, right? So you see two files now. One is PLT, which is the one that we don't want, ramping up the drain and auto ramping the gate to negative bias. But this one is what we want, right? So once I open, I look at the gate and then look at the drain. Do you see that? And looks like I did something wrong here. I also recorded this one, right? So this is wrong. Do you see my problem? I should not put here. I actually should only put here. Because when I put here, this file contained the curve that you were ramping down. Make sense? Yeah. So, but at least now you don't see the drain part, right? And anyway, this is, you see, they don't have the same thing because we run into convergence issue. That is just because I should not have make the mesh so bad, right? So we can try one more time. Go back to the mesh, right? I will just undo. Then when it is running, right? So it failed. It's good that it failed because it does not have the consistent solution when it's ramping up and ramping down. We're doing something called quasi-stationary. Quasi-stationary, for example, is a solve at 0.1 volt. It means you apply the bias at 0.1 volt and wait for infinite amount of time. So it settled down. So it should not depend on the history. So that's why when I saw, looks like I closed that curve already. But you remember the curve I just showed you, right? In random is like this. Ramp up, it becomes different. It should not be different. For transient, it might be because it depends on the history, but this should be wrong, right? And that is because it found the wrong solution or because of this bad match. But I'm glad that it failed. Otherwise, we will get the wrong result. Okay, so now we are running it again, right? So now, although it's lower, but convergence should be better. So let's just wait. Now, so while we are waiting, I want to say another thing now. It's good. You also was able to, what do you do? You were able to learn the Tickle script, right? So what I want now is that we want to extract different parameters from this curve. Okay, so we have gate. It is still running. Maybe this is the old result. Okay, but maybe it is running now. This is the new result. I hope that it converge. It's interesting that it doesn't converge this time when we ran down and then ran up. Okay, that's good. Let's try to solve the convergence issue. Another command we want to add is the precision. Okay, so let's put something called extended precision. This will make the precision higher. Okay, we will just keep the same physics, right? Let's try one more time, see. And also for quasi-stationary, we don't want to use extrapolate. So let's see if we will get a better result. And you already know what to do with the curve, right? You know that how to do a tickle script. But here I quickly show you something. Let's say I want to find the current at negative 0.4 volt. Right. So what will I do? Or I want to find the voltage that gives me a current that's 3e minus 6. Right. So I click on this probe. Right. And then I say Y. And then I put here. Do you see that? Then it gives me the current of this one. So why this is useful? Not useful now. I will save it. Let's just call it 10. Now then I'm going to add a new tool, which is the S-Visual. Okay, the first one, I'm still using tickle. Okay, I make it batch. Now I'm going to source this file. I'm going to import the file I just saved, which is temp.tcl. It means that it's going to copy it. So what will happen after I click OK, I right click, edit, tickle command. Do you see that it just record whatever I have done before, including the directory or whatever? Are you okay with this? The step again is just I try to create a new tool, not command, new tool, add, right? And then I choose S-Visual. From here. But then what is the content? I need to go to input file, say input. Import what I already saved from S-Visual. Okay. Why I want to import? In principle, I can just type myself, right? But I don't want to do that. I let it type it for me. Okay. So now when I look at the file, right click, edit, tickle command. Oh, delete the wrong one. I need to import again. So I go to property, go to here, import, and then temp, the one I just saved. I say OK, and then right click, open. This is what I did when I was doing this GUI, right? What did I do? I load a file, I do a 1D plot, and then I try to probe the device, the location. Is that okay? Yeah. So this is running. Convergence is not good, but we can try to do it, but it is running, right? So what is the point of this? Now, this is what I will do. I will delete the whole path. Okay? And then I'm going to replace. How do I replace in this tool? Find and replace. N103. What is N103? N103 is this node, right? I'm going to replace N at node. Okay? If you forgot, look at SWB tutorial. They are going to substitute this node with 103. Okay? So I'm going to say replace all. And what is the point here is that after post-processing, you will do it for each node, right? I will show you. Now, this command is important, right? This is something called tickle command, TCL. And it returns the value. So what do we want to return? Let's say I want to return, this is like the threshold voltage, right? Let me just call it VTH. Then you need to use tickle, set VTH. I just forgot all the command. Is this the right command? Set VTH. Do I need expression? I might not. This is the command itself. And then I ask it to print out something. I'm going to say put DOE : always have this. and then this is just the name. And then I'm going to put $VTH. I completely forgot all the command, but they are all in the tutorial. Let me just save it, okay? Let's look at this. This is almost done. Let's just wait until a little bit. So yeah, so now you see it has a smooth curve, right? Do you see that? But let's just wait it is slow. We need to wait until this is done to do the extraction, right? And at this moment, let's just look at the stringing again, right? It does have the pickle here, two command language, and you can learn it. And here particularly, it will talk about the DO. It doesn't talk about DOE. I thought you would talk about DOE. But yeah, but this is what we have. And then puts data. I might actually did something wrong in the syntax. If you go to, let's say, Google, right? Just Google and then say TCL put, right? Then it has the command. Just want to see how do I put variable with everything. Yeah, all you need to do just put dollar and whatever you want. So I think what is that right? No. This is to put in the file. This is to put in the file. Yeah, let's try. I think I can get this done. It should be okay. Let's try. Okay, so this is struggling to converge. 0.6. Conversion is worse than before. But so actually, yeah, it does has a king. This is something we need to study, why there is a king. But let's just wait a little bit more until it reach 1.5 volt. But at this moment, I can run this one. No, but I don't have file from here. So what I can do is still change it so that it will not depend on the. Do you want to try how to set no dependence? Dependency, relax. Okay, then even it is running, you still have to do it, right? I can show you. For example, I run both of this. Then I also run this at the same time, right? Then if you have the dependency, then 176 should not run. But you see that it run already, even 104 has not finished. Right. Now, do you see what I mean? It is running, right? Now for 175, I run into error. Let's take a look. I think it is I put the wrong name. Because when I try to load it, I try to load N175, but it doesn't have that file. Because I actually should load the file in front of it. So I did the wrong substitution at the beginning. Yeah. So when you load this, then it's going to change everything, right? So I need to redo the substitution. So instead of note, I should actually put previous. With this previous, it will also set the dependency, right? So I do it again, right? Previous. So let me try one more time. Now I will run this. Again. Cannot find the DOE. Yeah, VTH. So this is my command. I put the wrong thing. I should put maybe it's just like this. I forgot the command for it. Let's try one more time. This time it works, right? So it gives me this VTH. A lot of them, the reason is because we have a lot of value here. We're cutting horizontally, right? But this is not the value we want, right? We can easily just add a variable. Let me just call it I VTH. I say, okay, I want 1e minus 10 instead. Okay, and then in the input file, I'm going to put, instead of this one, I will just say add, oh no, not this one. Add I VTH. Yeah, very good, right? So this is a substitute. Then I will do it one more time. So when I'm doing it one more time, when it finish, now it gives me the correct threshold voltage, right? We can look at the plot. When 1e minus 10, right? We say, so let's just probe it. We change to y, 1e minus 10, right? So you can use arrow go up, right? Because when you click, it cannot be exact, right? It gives me 0.069 volts, right? This is exactly, okay. Are we using the right thing? So this depends on the interpolation actually, because now we are using log scale here. So there's a little bit difference in the value that it has extracted. And what we need to do is to put it in log scale. But when I probe it, I did not, when I create this script, I did not make it in the log scale. It was like this, I believe. Do you see what I mean? In linear scale, it has its own scheme, right? So if I try to run this command again, this, now you give me the same value, 0.064, right? Yeah. So maybe you say, hey, then that is bad. I don't want that. Then you don't need to redo everything. When we put it into log, you get this command. You just copy it, put back to here. After you plot the graph, you see? And now I run it again. Now you get 0.0695. Then this is the threshold voltage. Now, so you can do the same thing, right? To find the I on, I off, and also subthreshold slope. Because subthreshold slope is like, what is the subthreshold slope of a curve? It is like you define 2 points. Let's say I define it as 1e minus 10, and then I get the value at 1e minus 9. Then the difference in the voltage is the subthreshold slope. Maybe it's a little bit difficult to understand, but if we try to look at this file, it will be easy. What for the threshold voltage? We want to do it in log. Okay, and now then subthreshold slope is like what? You already have 1 for 1e minus 10, right? I can just do another one like this. I just repeat. It's easy. All you need to do is just copy, right? This time I call it 2, and maybe I make this 2. Maybe it is 1e minus 9, right? Then I have another 2, like 2 here. Or you can directly just put DOE, subthreshold slope, then it's going to be expression dollar $VTH2 minus dollar $VTH1. Do you see what I mean? Yeah. So for example, here I just add one more. I call it 2, and now I call it 1e minus 9, right? So what will happen if I try to run this node again? It will print both voltages, VTH1 and VTH2 and also give me the subthreshold slope. And I run into error because cannot read VTH1 because of my typo. I do not have VTH1, right? I only have VTH. I only define, yeah. So let me run one more time. Okay, then you give me the subthreshold slope, which is 72 millivolt. Is that okay? Yeah. So there are many other things you can do with this curve. For example, if you go to data selection curve and then probe, then the probe. Let me see. Look at the curve. Probe data. Where's the transform? Data. Write this thing of difference. Curve. Okay, here, analysis. You can also find the GM, right? You just need to put in this command. You can find, just do GM for now. Is that okay? Transconductance. This is the maximum GM. Okay, the maximum transconductance. Okay. It already something built in, right? So you just need to copy this command, right, to your script, and then it will print out. Is that okay? Yeah. So I will let me stop the recording now. Let me see. No, the GMS will come from just the analysis. It will just do it automatically for you. Let me stop the recording. How do I stop?